All right, welcome back to another video, and this video will be a continuation of chapter 8. This is 8.2 for statistics dealing with hypothesis testing. Okay, so the question says to use the results from a survey of a simple random sample of 1,050 adults, 91% rated themselves as above average drivers. We want to test a claim that 17 over 20 of adults rate themselves as above average drivers. All right, so it says identify the actual number of respondents who rated themselves as above average drivers, right? Okay, so that's the 91%. So we basically want to figure out what is 91% of the 1050. So to figure out the percentage of a number, you take that percentage in the decimal form. So that's going to be 0.91. And you're going to multiply by the number you're looking at, the sample size. So hit enter, we get 955.5. Let's go ahead and round that up to 956. And let's see, 956, that should be our answer. And it is, well done. Identify the sample proportion and use the symbol that represents it. The sample proportion is the 91%. They also call that p hat. So it all ties in together. So just get familiar with the lingo here. So we have p hat. Let's find p hat. There it is, p hat, and whatever number was associated with it. So sample proportion is p hat. All right. So 0.91. Excellent. Now for the hypothesis test, identify the values for the population proportion. The population proportion is always just a regular p, and it's equal to whatever your claim number is equal to. So where's our claim number? Remember, the claim number is usually inside of the same sentence that has the word claim in it. So it says, we want to test a claim that 17 over 20, blah, blah, blah. That's your claim number right there, 17 over 20. So let's go ahead and figure out what 17 over 20 is. So 17 divided by 20, we get 0.85. That's going to be our claim number for right now. So let's put in 0.85 and we are done. Good job. All right, next. Okay, so we have some information here. Feel free to read it. Let's take up the calculator. Okay, so look at this little box over here at the top right. Does it look familiar? It looks just like our TI-84 screen once we do the z-test and the one-prop z-test from the last video. So we're going to use this to answer our questions here. So they already did the work for us. So is this a left tail, two tail, right tail? Well, look at this little window right up here. It says that we're using less than. The proportion is less than 0.09. So remember, with less than tests, that's going to be a left tail. So remember, less than is for left, greater than is for right, and the equal to portion is for the two tail. Okay, what is your test statistic? Your test statistic is going to be whatever your z is. So right here, so they wanted 2 decimals, so 0.24. So 0.24. So in this question, they're trying to make sure that you know where to get your information from, the important stuff, the test statistic. Now they want the p-value. The p-value is right below the test statistic. They wanted 4 decimals, so 0.5944. You don't have to put the 0 in front. So 0.5944. And we got it. Okay, so what is the null hypothesis? The null hypothesis is always going to be HO. So you always have HO, and it's always equal to some value, just a regular equal to sign. And that's the only equal to sign here, and it's equal to our claim number. So remember, null hypothesis, your H0 will always be equal to something. Do not put the equal to with the slash when you're dealing with null hypothesis. Okay, null means 0 or nothing, so just make sure you put an equal sign. Okay, decide whether to reject the null or fail to reject. So remember, we look at our p-value and we compare it with the significance level. If the p-value is less than your sig, you reject. If your p-value is greater than your sig, you fail to reject. Look at your p-value here. 0.59 is definitely greater than 0.05. So we're going to go ahead and fail to reject. And we're failing to reject because it's greater. And that's what this whole section is about. They may throw some curveballs at us, but we'll be able to get over it. What is the final conclusion? Whenever you fail to reject, like in the last video, there is not enough evidence. So it's either going to be B or C. So let's see. There is not sufficient evidence to warrant rejection of the claim. There is not sufficient evidence to support the claim. Are we going to use warrant rejection or not support? Now, normally the warrant rejection stuff came with the two-tailed test, but remember, like I said in the last video, across the courses and statistics, it's not really consistent. I've seen it so many times. Whatever the right, we're gonna guess, and whatever the right answer is here, we're gonna try to apply it to every time we get this type of question. This is a left tail test. We're failing to reject. Let's just keep it in mind. Usually the warrant rejection stuff came with two tail. Let's go ahead and choose C just for the heck of it. Watch, it's going to be B. It is C. Okay. We'll take it. So don't use warrant rejection. For now, we're going to say we're not going to use warrant rejection until we have a two tail test. And that's what it was for me back when I was taking this course. I don't know. All right. Anyway, let's go ahead and do similar question. All right. Okay, this time they give us test statistic again. We have a plus or minus for the critical Z. And if you may recall, whenever you have two critical Z values, that's a two-tailed test. Okay, let me see. Is it a two-tail? Yes, it's a two-tail because we have two different critical values. All right, so so remember, with the two critical values, you're always going to have a positive and a negative version of those. So you have a plus 1.64 and a negative 1.64. Okay, what is your test statistic? It's whatever your Z is. They wanted 2 decimal places, so 1.14. What is your p-value? It's right below your test statistic. And it says in literal plain old English, p-value, so 0.254. What is the null hypothesis? The null hypothesis is based on your claim. So what is our claim? Let's read this thing. In a newspaper survey of 442 people, 52.7 said that we should replace passwords with biometric security. Let's keep going. The accompanying StatDisk display results from a test of the claim that half of us say we should receive passwords with biometric security. I think this is going to be a little tricky one. But there's our claim number. Our claim number is definitely going to be 0.50. Now, what about the P? Is it less than, greater than, or equal to? The thing is, they like to play word games. Now, I don't see any words saying that this is a less than or greater than. And usually when you don't have a less than or greater than, then it's the equal to that you're going to choose. So they want us to use HO for this one. So it's definitely going to be equal to regardless. But my concern was the alternative hypothesis. But let's keep on going. The null hypothesis HO, where P denotes the population, say that we should replace password to Oh, what is the null hypothesis? Let's go ahead and compare the p-value to your significance level. Our p-value is greater than our sig, so this is a fail to reject. So we fail to reject the null, and that's what we're going to roll with. Yeah, there we go. Got a little, I don't know, it's kind of weird how they presented it. Okay, what is the final conclusion? Whenever you fail to reject, there is not enough evidence. And we're going to say to support the claim. Yeah, that's the thing. Are we going to use warrant rejection or support? To me, I thought that this was an equal to because they never said less than, they never said greater than, and normally when they never say less than or greater than, this is a matter of equality. So I thought this is a two-tailed test, and with two-tailed tests, I remember always using warrant rejection, but we're going to see if we get it, and I hope it is. Yep. All right, so I think it's safe to say that with two-tailed tests, it's always warrant rejection. Okay. But we'll see how long that stands. Statistics is just so fickle. All right, let's take a look at this one. Okay. Let me see. Let P denote the population. Identify the null and alternative hypothesis. Test the claim. All right, we're testing a claim that buttered toast will land with the butter side down 50% of the time. They never said less than. They never said greater than. The HO is always tied to a regular equal sign. They never said less than or greater than. I'm going to choose a two-tailed test for does not equal to. The claim number says 50% of the time, so we're going to choose 0.5 for here and 0.5 for there. Let's see what happens. Excellent, good. I'm glad we're getting them right so far. All right, what is the test statistic? Now we're going to use the calculator. Did they give us the test statistic? Doesn't look like they did. And that's fine. We're going to use our calculator to figure it out. Okay, so let's open up our calculator. All right, remember this is a TI-84 calculator. It does the job. All right, so what do we have here? We're going to go to stats. We're going to go to tests. This is proportion is not giving us standard deviation or means. So this is going to be a 1 prop Z test. Now it's asking us for our claim number. Our claim number is going to be the 0.5. Our X. So the X is always smaller than your sample size. It says when 46 buttered slices of toast were dropped. So the sample size is going to be 46. And your X is always the smaller number. That's it. So 28, I guess they're dropping them and see if it's going to land. Oh, wait a second. When 46 buttered slices of toast were dropped, yeah, that's your sample size. 28 of them landed with the butter side up and 18 landed with the butter side down. So we can't just put 28 for right now. We're going to have to hold off because it could be the 18. So judging by what we're trying to test a claim on, judging by that, that's the number we're going to put down. So we're testing the claim that the buttered toast will land side down. So you need to focus only on the side down portion. So 28 was side up, butter side up, 18 was side down, and that's what we need because that's what we're testing. So we're going to use 18 as our X. Yeah, so don't be so quick to jump the gun like I almost did. All right, we're going to choose the equal to, or does not equal to, hit calculate, and there goes our statistic stuff. So 2 decimal places are needed. So this is negative 1.47. Let's go ahead and put that here. Negative 1.47. Well done. P-value is right below it. They wanted 3 decimal places, so 0.140. Well done. Okay, so we're testing the claim now. So state the conclusion. Do we reject, fail to reject, blah, blah, blah. Okay, so our p-value, remember we always test the p-value against our sig level. What is our sig level? Right here, 0.05. So our p-value is definitely greater than 0.05. So this is a fail to reject. When you fail to reject, there is not. And this is a two-tailed test. We're going to try to see if warrant rejection is going to work. And it works. Okay, I promise I'm not paranoid. It's going to come in time and watch. Okay, write a conclusion that addresses the test that the tote will tote. A typo. This is the first time I've ever seen a typo in this program. Anyway, let you guys see that. Okay, so it says write a conclusion that addresses the test that the toast will land with the butter side down more than 50% of the time. It says more than 50% of the time. All right, so we're going to keep going. We're going to basically restate everything that we just wrote a little while ago. Let me make sure everything is okay. Let's see. Now, over here, it doesn't say more than, right? Identify the null alternative hypothesis to test a claim that the butter toast will land face down 50% of the time. It doesn't say less than or more. So, you know what? HO is still going to be equal to no matter what. And we're going to use 50% again based on what we have here. So 0.5. Let's go ahead and put 0.5 here as well. Now it says more than. So more than means greater than. That should be correct. So basically they want us to basically figure out if there is or is there not. So we have to test the claim again, but it's not going to take too long. Let's go to stat. Let's go to 1 prop z test. And everything is the same except for this guy here. We're going to choose greater than this time. Go down to calculate. And let's see if we got a little bit of a difference. Yeah, that p-value is really, really high. But it seems like it's still gonna, yeah, because our p-value is still very, very high. We have 0.93, and that's definitely greater than 0.05. So we're gonna fail to reject again. And when you fail to reject, there is not enough evidence. Got it. Yeah, there's a structure to this. It works. It works mostly. All right, let's see what we got. So help me solve this. Okay, so moving right along. Identified the null and alternative. So let's look for that claim number. It says more than 20%. So HO will always be equal to. So we can eliminate B because it always has to be an equal to no matter what kind of claim that we're doing for this course. Okay, so HO is equal to 0.20. And they said more, so we need the greater than, and it has to be that one. All right, well done. Identified the test statistic. So we're going to go to our calculator here. Okay, let's start putting the numbers in. Stats, tests, 1 prop z. Okay, your claim number is going to be 0.20 this time. Let me see. 218 subjects were treated with the drug that used to treat. All right, so there goes our sample size. So 218. And what about the other number? Okay, are we testing claims of developing nausea? Yeah, 54. So that's it. It's usually the smallest number, the smaller number, I should say. All right, enter 218, enter. All right, we're doing greater than. So greater than is already selected. You know, you can hit enter on it, hit calculate. Bam, here we go. So test statistic is whatever your z is. They wanted 2 decimal places. So 1.76. All right, fantastic. P-value is right below it. 3 decimals, 0.039. All right, excellent. All right, so your p-value here, let's compare it with the significance level. 0.039 is definitely less than 0.1. So this is going to be a reject. So it's either B or C. When you reject, there is enough evidence. You see, I don't even have to read the rest, but you make sure you read the rest as well. You know, before I erase this, nope, never mind, we're good. All right, let's go ahead and take a look at it from a clean slate. Okay, so let's go ahead and find a claim number. I'm just going to skim for the claim here. Let's read the whole thing. A poll of 1,002 Americans showed that 46.7% of the respondents preferred to watch the news rather than read or listen to it. Use those results with a 0.05 significance level to test a claim that fewer than half of America. There it is. This is the word. This is the word claim. And here's the number that's associated with it. Half. Isn't half 50%? Yes. So that's our claim number. So HO is always equal to. Now they said fewer. Fewer means less than. So we're going to choose the less than. All right, fantastic. Now what is the test statistic? The test statistic. Yeah, sorry, you guys had the calculator in your way. I'm sorry about that. All right, well, we're going to put the calculator on again anyway. All right, test statistic. Let's go to your warm prop Z test. All right, our claim number is going to be 0.5. Let's put our sample size since we're here. 1002 is our sample size. Now it says that 46.7% of them prefer to watch the news than to read or listen to it. So we have to figure out what is 46.7% of the 1002. So let's change it to a decimal by moving 2 places to your left. So 0.467. We're going to multiply by our sample size, which is 1002, and enter. We get 467. Let's round up to 468. All right. We're choosing less than for our claim test. We're going to go down to calculate. There it is. So your Z this time is going to be negative. They wanted 2 decimal places, negative 2.09. All right, p-value. P-value is going to be 3 decimal places, 0.019. All right, very nice. Now, conclusion, your p-value. What is our sig level? 0.05. We have 0.01. Our p-value is less than our sig. So this is going to be a reject. When you reject, there always is. And this is a one-tail test. So let's see if support is going to work out for us. And it does. Seems like they're compliant for now, but don't drop your guard. I don't know. Sometimes there's shenanigans. All right, let's go ahead and do this from a clean slate. Okay, so a random sample of 824 births included 413 words. That's a claim. Okay. Now, they never said less than. They never said greater than. So we're going to choose the equal to, and it cannot equal to. All right, see how I just do like deductive reasoning for that? All right, identify the test statistic for this hypothesis test. So let's go ahead and go to our calculator. Okay, one prop Z. One prop Z test. Okay, our claim number is 0.515. So 0.515. What is our X? Well, okay, are we talking about boys or girls? We're testing claims for boys. How many boys do we have? We have 431 boys. So let's go ahead and put that here. So 431 boys. What is our sample size? 824. What symbol did we use for our H1, our alternative hypothesis? We use the equal to symbol, or the does not equal to symbol. And go to calculate. There it is. So identify the test statistic. We're going to have 0.463. Haha, fear not. 2 decimals. 0.46. On p-value. Our p-value is going to be 3 decimals. This is 0.643. Right, good job. Now, the p-value is definitely greater than your sig. The sig level is right here, 0.05. Is greater. The p-value is greater than 0.05. So when it's greater than, you fail to reject. So it's either going to be A or C, and we're failing to reject. Whenever you fail to reject, there is not enough evidence. Okay, the results support the belief that 51.5% of newborn babies are boys. Well, there's not enough evidence to support that claim. So we're going to hit do not support. Let's see, because there was sufficient. Now, there wasn't any sufficient evidence. So there is not. Yeah, I'm going to stick with this. If it's not this, then we're going to choose the other one. And this sucks, but that's just the way it is sometimes. But we got it right. They're compliant today. They're being nice. I wonder why. All right. I guess there's no point in, erasing this in its entirety. Let's go ahead and erase that little thing right there. Okay, so for our claim number, it says test a claim, blah, 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 blah. 24 will be yellow. So they never said less than, they never said greater than. So you choose the equal to, okay? And look, we did. We chose the cannot equal to. And HO will always have an equals to. If you don't see an equal to sign for your HO, for your null hypothesis, if you don't see an equal sign, you can eliminate it like this right here. This HO here has a cannot equal to. That's not good. Also, we can't use that. We can't use that. So it's this one. Let's see. Test statistic. You know what that means. We're going to go over to, and notice that we didn't have to use any scratch paper or anything. So maybe we can bring this calculator over so it's not in the way so much. Okay, so now what? All right, 1 Prop Z. Okay, what is our claim number? Our claim number is going to be 0.24. What is our X? Well, what are we testing the claim on? We're testing the claim of the yellow peas only. So be very careful, okay? Your X is going to be the number of yellow peas because that's what we're testing. The claim is based on yellow. So your X has to be the yellow. So that's going to be 172. Now your N, your sample size, the whole enchilada, everything added together. They didn't give us everything as a solid number, but they did give us a number of greens and they did give us a number of yellows. So we can find the total by adding them together right here in this calculator menu. So 431 plus 172. Yeah, so don't be so quick to just say, oh, the N is always the bigger number each and every time. No, be careful. You have two different colors of peas in this case. So you need the total number of peas. You add them together to get the 603. Very important. Don't let them trick you. All right. So we're going to choose the does not equal to symbol, hit calculate, and there goes our statistics. Okay, so test statistic is going to be whatever your Z is. They wanted 2 decimal places, so 2.60. And you don't have to write the 0 at the end. P value is right below it. Your P here in the calculator is, they wanted 4 decimal places, so 0.0093. Okay, your P value, let's see our significance level. Our sig level is 0.05. Our P value is 0.0093. Whenever your P value is less than your sig, you reject. So it's either C or D. Whenever you reject, there is enough evidence. Oh, but they're talking about less than and greater than. Yeah. We're rejecting because it's less than or equal to our sig level. Okay, whenever you reject, there is enough evidence. So it's either going to be C or D. So it's asking us, are we going to warrant rejection or support the claim? What kind of test is it? It's a two-tailed test. And so far, you've seen it yourself. Whenever we have a two-tailed test, we use the word warrant rejection. And we got it right. All right, so let's see what we got here. Claim number less than 80%. Yep, you have equal to next to our HO and less than for our H1, our alternative hypothesis. So that checks out. Test statistics. So really quickly, One prop Z test. Claim number 0.80. Your X. Let's see what they're talking about. We're testing the claim. They're talking about correct. So we want the number of corrects. Number of corrects is going to be 77. Let's put 77 here. And sample size is going to be 99 in total. And we're using less than. And calculate. All right, test statistic is going to be whatever your Z is, negative 0. 2 decimal places, 5. Well done. P-value. And you see, this is all we do in these. If you have good technology, use it and abuse it. It'll take you right through the course. You just have to do little intricate conclusions, like whenever your p-value is less than your sig, that means you reject. When your p-value is greater than your sig, you fail to reject. If you ever reject the null hypothesis, there is enough evidence to support your claim. If you fail to reject your null hypothesis, there is not. And that's what we use when we're judging these. Okay, so identified the conclusion. Our p-value is 0.29. Significance level is 0.01. It's greater than, so we're going to fail to reject. There is not. Fantastic. Okay, let's see if we can just explain how we got this. Let me see. She was 9 years of age. She flipped the coin. All right, she flipped the coin. She asked therapists to identify. Blah, blah, blah. Okay, so here it is. Use the 0.10 significance level to test a claim. That touch therapists use a method equivalent to random guesses. A random guess basically is a 50-50 chance when you're flipping a coin. So that's why our claim number is going to be 50%. So just remember that if you get this in your exam or something, just make sure you put 0.5 because that's an equal chance of flipping a coin, All right, test statistic. You know what comes next. So stats. We're going to go over to one prop Z. Claim number is 0.5. All right, let's see what they were saying. It says among 278 trials, so there goes your sample size, 278. It says the touch therapists were correct, 122. So they want us to test a claim for correctness. So go ahead and put 122 in for your X. All right, we're going to use the same symbol. And let's make sure test. To test a claim that touch bars using as equivalent. Okay, they never said. Oh, let P denote the population proportion of correct. There we go, right there. So that's how we know we're choosing the correct X. If we're not going to use the 122, we would have to figure out what the incorrect values were, and we will subtract. But luckily for us, we don't have to worry about that. All right, calculate. Bam. Test statistic. Negative 2 point. How many decimals? 2. 0.04. P-values right below it. Now, if you didn't have the calculator, you would have to find these values inside of the inside of your book, but it just takes so long. Like looking in that table, it takes a little while longer. It's not too long, but still, you have to be careful. It's somewhat, troublesome. Compared to the calculator, everything is troublesome in comparison. In opposition. All right, state the conclusion. So our p-value, which is 0.041, is less than our sig, so we're going to reject. When you reject, there is. Now we're using the two-tailed test, so we're going to say warrant rejection. Using more the results. So, Okay. Now the math is done. We have to see and make sense of what we have here. And you know what? See, the results suggest that touch therapists are. What if I would have randomly guessed this and just committed to memory for the future? Let's see if we get it right. Be a pessimist, yeah. just look at the subject matter with this particular question right here. About the flipping of the coin, and the therapist, and the seeing, and the stuff without touching, and blah, 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 blah. If you ever get that you're rejecting and there is enough evidence, just put do not suggest that touch therapists are effective, okay? Just, subject matter is not really, I don't know. All right, anyway. All right, here we go again. Let me see. Consider a sample, blah, 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 blah. Like greater than 1/2, that means that your HO has to be equal to and your P has to be greater than 0.5. All right, it's legit. Test statistic. You know what comes next. Stats. Okay, 47 football games. That's going to be your sample size. Okay, let me see. 30 of them here were won by the home team. To test a claim, home team wins. Okay, so that's going to be our X, the number of home team wins. So this is 30. Let's see, greater than, same symbol as your alternative hypothesis. Hit calculate. There it is. The test statistic is going to be 2 decimal places, 1.8. Add the 1 to it because it's 6, so it's going to be 1.9. P-value. Oh, 3 decimal places. 0.29. Okay. Our p-value is greater than our sig, so this is a fail to reject, and there is not enough evidence to support the claim. Oh, good. They didn't ask us for that inference stuff later. Oh, look at this. Yeah, look at this. All right, let's just go over this. Let's memorize this answer that we got last time. There is sufficient evidence to support the claim that the selection process is biased towards them. All right, let's see the other one. Okay. Okay, so let's just keep in mind that it's not fair, and you're gonna see that's the same one we're gonna choose, and that's just the way that these things work out. Okay, let me see. They have 78.6 here in all of these solutions right here, so that has to be our claim number. There's no way it's not. So among that's the claim is biased against. Now here's the thing. It says biased against. I thought biased against would mean that it's different. So we're gonna have an HO with an equal to sign, that's for sure. So it's either gonna be C, E, or F, right? It says biased against. Biased against. Let's try to equal to. It wasn't correct. So biased against, if it's biased against something, let's just try trial and error. Let's try to less than. Okay, so look, I'm not familiar with that term biased against. I thought biased against means that you were not for it. I would have chosen the equal to. So look, for your exam, for your quizzes, anything that you have to deal with it, you deal with something that says biased against, choose less than. I know it seems almost like it's robotic, but like, look, this video is meant to help you out, help you understand what they want. Maybe your professor can explain it better about why we're choosing less than, but it happens this way. I know if I were to take this exam and I have this question, I'm choosing less than if I see biased against. Don't care. All right, you want to get an A, right? Anyway, it sucks that, it's not consistent. The math is always consistent, but I have one Prep C test. Claim number is 0.786. Let's find what we need. There is our sample size. Now that they give us a percentage to go with that, it says we have 35%. So let's take 0.35. We're going to multiply by 884. You get 309. Let's call that, we'll just take away the decimal portion. We can say 310. biased against. We're going to choose less than, I guess. It's when you combine English into math, you get a messy little thing. I don't know. Maybe they have their own little I guess logic to doing this. I don't know it. Maybe you can explain to me in the comment section. Who knows? All right, p-value is 0. So this is definitely going to be a reject. So we're going to reject because it's less. And remember what I said? Just look for the part where it says unfair. All right, and there is sufficient evidence unfair. I'm not even going to read all the other stuff, and we just cheesed it out. But look, that's just the way this course is. That's just the way it is in statistics. Once again, if you want more, if you're going to make sure you're not doing a guessing game, go ahead and learn the inner workings of it. I don't have time for that. I'm here to help you out with the math. Anyway, see you in the next video.